To keep gravity from collapsing the universe, Einstein postulated a force equal to and opposite gravity. This constant force perfectly countered gravity to achieve a static universe. Einstein searched for this cosmological constant, convinced it was hiding in his equations. But he was wrong.
If Einstein had the courage of a conviction on something, he would have recognized that the static universe he believed in was not compatible with the theory that he'd come up with.
The expanding universe fit nicely into a theory called the Big Bang.
Why people were so enthusiastic about a universe which had a finite beginning in what I suppose he thought was the recent past, a few billion years. He just never accepted it.
But accepting the Big Bang theory and thinking it flawless are two different things. There were problems with the details of the theory, expanding problems. During the latter days of the 20th century, scientists examined problems with the Big Bang, even though the theory was generally accepted. One of the biggest problems was that the temperature in outer space was strangely uniform. Physicists didn't expect that the universe would have the same temperature roughly everywhere they looked. The universe is simply too large for one end of it to be the same temperature as another. Yet it is.
It's the same thing that happens if you have a bathtub full of cold water and you pour in some hot water in one extreme. It's going to be a while before the whole bathtub has tepid water, because it takes time for that hot molecules to propagate across and normalize the whole distribution.
The universe doesn't appear to be old enough for its temperature to have equalized yet. It was still small.
We don't know exactly when inflation happened. Most likely it happened when gravity had split off from the other three forces, but at a time when the other three forces were still very likely unified.
The Wilkinson Microwave Anisotropy Probe, or WMAP mission, planned to photograph the fossil remnant heat of the Big Bang that Penzias and Wilson had found. In other words, NASA wanted to take a baby picture of the universe that they could then compare with how the universe looks today. In February 2003, scientists got their first glimpse of WMAP's picture of the baby universe when it was a mere 380,000 years old. The clarity of the data stunned scientists.
The reaction people had when they saw this was, wow! It really was the way people had been speculating earlier on. Inflation probably happened.
To the untrained eye, the WMAP image looks like a speckled robin's egg. But to scientists, this was a stellar Rosetta Stone. These patterns represent the seeds that later grew into the vast expanses of stars and galaxies of today. Besides strongly supporting Gouth's inflation theory, the data also gave us concrete clues to the age, composition, shape, and evolution of the universe. All rocky and metallic cores behind. The distant planets, no longer held by the less massive sun's gravity, drift into the vastness of space. Travel billions of years after that, and all remaining heat from the sun has radiated out, and its small, dark surface is the same frigid temperature as the rest of space. The sun is now a black dwarf. Now, billions of years later, propelled by a mysterious and only recently discovered dark energy, the universe expands ever faster, flying apart everywhere. On a grand scale, and at a molecular one, expansion overwhelms gravity. Everything rips apart. Not just galaxies, solar systems, and stars, but even atoms. Finally, matter itself is torn asunder. This is the big rip, the big rest in peace for our universe, the legacy of dark energy, that stuff we still haven't figured out.